In this illustration, we are given a uniform rod of mass m, length L. You can observe here this is a uniform rod, that is mass is uniformly distributed over the length and it is having mass m, length L. It is tied to the vertical shaft. This is the vertical shaft and it can rotate in the horizontal plane about this vertical axis with angular velocity omega. Okay. How much horizontal force does the shaft exert on the rod? We need to calculate the force exerted by shaft, this vertical shaft on the rod. Okay. Here we are considering gravity free space. That's why this rod is rotating in the horizontal plane. Okay, without inclination. So we are considering the space is gravity free space. So let us do one thing. Let us make the diagram to the next page. This one. Our requirement is to calculate force exerted by shaft on the rod. So for making free body diagram, we need to isolate shaft and rod. That's why we are going to select rod as a system. This rod as a system. Now let us find what are the external forces acting on the system. As we have considered this as a gravity free space, that's why we need to bother about the weight of the rod. The external force only will be the force exerted by shaft on the rod. Now question arises, in which direction this force should be, in the leftward direction or rightward direction. Okay, as we know, this center of mass is rotating about the shaft. That means it should have net force in this situation of the diagram in the leftward direction. That means centripetal force should be toward the leftward direction. That means in this situation given in the figure, the net force applied by shaft on the rod should also be in the leftward direction. Let us make the diagram of this force, this one. Let us consider this force is capital T. Okay, that's why we have made this capital T. Now center of mass of the rod will be at a distance L by 2 from the center of rotation. So centripetal force acting at this position should be equal to omega square L by 2. This will be omega square L by 2. Okay, now we can apply Newton's second law, or you can say equation of circular motion for this case. For the center of mass, we write F external equal to mass multiplied by ACM. This one, right? F external, it is nothing but capital T in the leftward direction. Acceleration, as we discussed, it is again the leftward direction. So here we can write capital T equal to m multiplied by omega square L by 2. This is the force exerted by shaft on the rod. Okay, this is the horizontal force, this one, 1 by 2 m omega square L.
Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.